Look outside: green trees, stable ground, predictable weather. We take the sheer tranquility of our planet as a given, a baseline reality. Go back 4 billion years to the Hadean Eon, and this exact same space is an unrecognizable ball of boiling magma, devoid of a single drop of water or sign of life. Every feature necessary for life, from the atmosphere to the core, is a direct result of catastrophic cosmic destruction. Earth never grew peacefully into a habitable world. How did the universe's most destructive forces build a perfect sanctuary for life? To understand our existence, we have to trace 4 vital features: the solid ground we stand on, our magnetic shield, our oceans, and our climate, back to the specific apocalyptic disasters that created them. About 4.6 billion years ago, a peaceful cloud of dust and gas called a solar nebula was drifting in quiet space. A nearby supernova sent a shockwave that violently collapsed the cloud, igniting the sun at its center. This model of a protoplanetary disk shows the leftover material. The remaining dust started colliding and bonding together through accretion. Over millions of years, gravity pulled these clusters into massive, high-speed impacts, scaling up the debris into the early Earth. Empty gas and microscopic particles don't turn into a solid planet by sitting still. The intense kinetic violence of accretion was the absolute mandatory physical mechanism required to build a solid foundation. As you can see in this photo of modern churning lava, constant impacts from space debris generated massive amounts of heat. That kinetic energy melted the early Earth entirely into a global sea of liquid rock. This diagram shows differentiation. Total melting allowed gravity to pull dense iron to the core, while lighter elements bubbled up to form the crust. Extreme pressure keeps the iron churning, generating massive magnetic field lines that encase the planet. Without the hellish heat of those early collisions driving differentiation, the iron never sinks. Without an iron core, we have no magnetic shield, and solar winds would have stripped away our atmosphere billions of years ago. Even with a crust and an atmosphere, you need liquid oceans. Water didn't simply materialize out of thin air onto a boiling rock. It was delivered violently. For millions of years, Earth endured a relentless bombardment from comets and asteroids, carrying ice crystals from the freezing outer edges of the solar system. When these icy rocks smashed into the molten surface, they vaporized into immense clouds of steam. As the planet eventually cooled, that steam condensed and rained down continuously for millions of years. The vast oceans that currently absorb atmospheric heat, capture carbon, and sustain life are, in reality, the accumulated scars of an ancient cosmic bombardment. About 4.5 billion years ago, a Mars-sized protoplanet named Theia slammed directly into the molten Earth, blasting a massive ring of debris into orbit. The dense metallic core of Theia sank and fused with Earth's core, while the ejected debris cloud coalesced gravitationally to form our moon. We know this happened because of physical evidence, like this lunar soil sample from the Apollo missions. Scientific analysis reveals the moon's basaltic rock and oxygen isotopes perfectly match Earth's mantle. As this orbital model highlights, the sheer force of that impact had a hidden, long-term consequence. It permanently knocked Earth's axis to a 23.5-degree tilt, altering how much solar radiation each hemisphere receives. This collision gave Earth the rhythms necessary for complex life. The moon's gravitational pull created the intertidal zones that bridged the gap between sea and land, while the axial tilt established the seasonal cycles that prevent the climate from locking into lethal temperature extremes. Every stabilizing force we rely on, from the oceans to the magnetic field, represents a permanent record of ancient cosmic violence. We orbit at the exact right distance from the sun. We have the precise amount of volcanic activity to drive the greenhouse effect, and a perfectly calibrated spinning iron core. The mathematical probability of all these chaotic events happening in this exact sequence is staggering. A slightly smaller asteroid bombardment, or a slightly different angle of impact from Theia, and Earth ends up as barren as Mars or Venus. Because we are the product of a narrow chain of specific accidents, our ecosystem is an extreme, fragile anomaly in a hostile universe. Tracing the 4.6 billion year gauntlet of destruction required to build this environment proves the sheer rarity of our world. It clarifies why humanity has an undeniable, urgent duty to protect it.